Hello, everyone. I'm Antoine Vastel from DataDome, and today I'm going to talk to you about residential proxies and bad bots. First, let me start with a quick introduction to bots and proxies. What's a bot? Basically, it's a program to automate actions on the web. It can be used for positive purposes, like search engines that want to index your website, testing automatically your website. But it can also be used for negative purposes, for example, to conduct DDoS attacks, credential stuffing attacks to steal user accounts. You can make bots using different kinds of technologies, like HTTP clients, Node.js, Python, Go, or you can use, real browsers or automated headless browsers. Basically, it's a trade-off between, like computational resources, features available, like headless browser will have, native JavaScript execution. It will have a more realistic fingerprint, whereas, HTTP client may be more easily detected if you don't modify them. How can we detect bots? There are a few categories of signals that you can use. Some of them can consider like signatures, sort of fingerprints, browser fingerprinting using JavaScript, TLS fingerprints, HTTP fingerprints. You can also collect behavioral signal using JavaScript. For example, have a look at the mouse movements or the way the user is, touching his screen. But you can also have a look at the way, the sequences of requests, the sequence of requests made to the website. For example, are you making a request to a product page before doing a add to cart? Then you can have a look at different kind of reputations, like IP address reputation, session reputation, and proxy detection, like is the IP address a proxy? And finally, contextual information like the country, the time of the day, the website targeted, is everything consistent? Okay, so why do we care about proxies when it comes to bot detection? At some point, as an attacker, if you have a lot of bots, you will need to get access to thousands of IP addresses to scale your attack, because otherwise it will be easily detected. So you want your attack to come from a lot of IP addresses to make it look like the traffic of your attack is coming from thousands of different legitimate devices. So traditionally, websites implement simple techniques to protect their website against bots. They will use IP-based rate limiting. So as an attacker, if you do like 1,000 requests per minute, maybe you will get your IP blocked. So as an attacker, what you want to do is use a proxy, because it will enable you to avoid IP-based rate limiting techniques, because you will spread your attack on different IP addresses. But you can do more. For example, use residential proxies. Because if you use a residential proxy, so this is a proxy that belongs to a well-known ISP like Comcast, AT&T, Verizon, then you may be able to bypass as well reputation-based blocking. Because some websites may be more aggressive with data center IPs. For example, if you make requests from an Amazon IP or Google Cloud IP, some websites will consider it suspicious and may have lower thresholds for rate limiting or may just block you. I don't say it's the right thing to do because you may block users with VPN, but some websites do it. But you can go even further. If you use residential proxies that are located in the same country as the website you target, so for example, you want to attack an American website, maybe this website has geo-blocking, so they will only allow requests coming from American IPs. If you use residential proxies that are located in the US, then you will be able to bypass rate limiting, reputation-based blocking, and avoid geo-blocking because the IP addresses are located in the US. So from the point of view of the website, it looks like it's legitimate traffic. And it's quite easy as an attacker to get access to proxies, in particular residential proxies. So I put 2 screenshots, but there are a lot of services that make it really easy for attackers to buy proxies. You pay depending on the distinct number of IP addresses and the bandwidth. And most of the time, you can select the country of your IP addresses. So you can decide, to choose US-based IPs or European IPs, depending on the website you want to target. So what we did is we conducted a study during roughly a year, and we wanted to estimate, like sort of upper bound of proxy IP pool size. So we studied 5 proxy providers and bot as a service. So what we call a bot as a service, basically just a service that exposes an API that make it really easy for people that want to make sophisticated bots without having bot knowledge. So these services, they expose an API, and that you provide the URL of the page that you want to target, and then they will take care of creating a browser in the cloud, rotating the IP address, forging the fingerprint. So you don't need to be a bot expert. And so we collected proxy data in a passive and active ways. So we subscribed to proxy services and bot as a service, and we also monitored traffic with signatures of bot coming from a certain bot as a service on our customers. So we did it during 11 months, from April 2022 to March 2023. And in total, we collected around 354,000 proxy traces. So basically, every time we're making a request, or a bot as a service was making a request to one of our customers, we were tracking it. And it represents roughly 30 million distinct proxy IP addresses. So this is the time series of the data we collected over time. We didn't start the collect of all the proxy services and bot as a service at the same time. So it evolved over time. And here, what we see is the top unique proxy IP per autonomous systems that we observed during the last year. And we see that the autonomous system with the most number of proxy IP is Turk Telecom, with more than 848,000 distinct IP addresses that were used as residential proxies. And then we see well-known autonomous systems like Comcast or British Telecommunication with more than 600,000 residential proxies. And if we have a look at 2 autonomous systems, so the first one, Comcast. So Comcast, the 7922 autonomous system had roughly 20 million IP addresses. So it means that during our study, around 3% of their IP address were used as a proxy at some point. And if we look at Turk Telecom, it's even worse. Actually, they had 2 main autonomous systems, and it means that more than 11% of their IP addresses were used as proxy at some point. So it means that, a lot of IP addresses are used as residential proxy at some point because people have infected devices or they install, application with shady, SDKs. So it can be quite dangerous to block every kind of IP just because it is a residential proxy, because these IP addresses, they are shared by bots and human users. So you don't want to just block them, but you still want to know that this IP address was recently used as a proxy to leverage this in your analysis and in your detection. If we look at the geographical distribution of residential proxies, we see that USA had more than 3 million residential proxies, followed by Great Britain with roughly 2 million. But basically, we see IP addresses, residential proxy IP addresses located all around the world. No countries, all countries are impacted. We also had a look at the overlap between the different proxy providers and bot as a service. Basically, as a company, you may want to get this kind of data by yourself, and you may want to know what's the most cost-effective way to get this kind of data. So you could subscribe to a service, or you may want to subscribe to a residential proxy service yourself. And basically, we observed some services with huge overlap. So this is a sort of correlation matrix, and on each, on the left, you have the different proxy providers and bot as a service we studied. And on the top, we have the same proxy providers and bot as a service. And we see that some of them have a huge overlap. For example, the proxy network A has more than 89% overlap with bot as a service E. And we see the same thing with bot as a service D and proxy network C. So basically, like some bot as a service heavily rely on some, proxy providers. So if you want to enumerate all their IP addresses, it may not be useful, to subscribe to all the services. You may be able, to subscribe to a few of them And most of them use the same services behind the hood, so no need to pay all of them. Okay, so now I'm going to talk about our approach to detect residential proxy IP addresses using machine learning that we use in production. So the first thing we want to do is create a data set that contains two categories of data. The first category is data related to residential proxy IP traffic, so like positive cases. And the second one is non-proxy residential IP traffic, so the negative cases. To detect residential proxy IPs, we use the fact that traffic coming from shared residential proxy behaves differently than traffic coming from legitimate shared IP addresses, even though both are shared. Because residential proxy IPs, what we observe is that they tend to make requests to a lot of websites that we protect, and they tend to make requests to websites that we protect, but that are not even related. They may be related in a lot. They may be located in a lot of countries, and traffic on these IP addresses tend to make a low volume of requests per session, which makes sense given the fact that attackers, they often use proxies in a rotating mode. So, their bot will make a request or two and then, use another IP to continue, and so on and so on. So, which is not what a human user would do. And they also have a higher diversity of fingerprints, which also makes sense because bot as a service, for example, or bots, they will randomize user agents, accept language headers, etc. And so, every time they will make a request, they will make a slight change. And this is not something you observe with a legitimate shared IP addresses because most people, they have an iPhone or Android device, and they don't change their fingerprint at every request. So we use this knowledge to extract features for our machine learning models. And basically what we do is we compute behavioral features aggregated at the IP address level. So for each IP address on a given time window, we'll compute the number of HTTP requests, the distinct number of websites requested by the IP address, distinct number of user agents, distinct number of accept language headers, and the average session duration, number of requests per session. And once we have these features, we can train our machine learning model using CatBoost. So CatBoost is a gradient boosting tree library developed by Yandex, and it's really convenient because data scientists can use, the library in Python, which is, the kind of language that they use. So it's really convenient for them to train the model. But then it has, the same library is also available in Java, C++. So if you want to use it in real time, which is our case, then it's really convenient. You can have a good performance, low latency, all while making it easily usable by your data science team. So we use grid search to optimize CatBoost hyperparameters and our own models hyperparameters. So in our case, it's mostly the time window because we want to compute behavioral features, but we need to decide, if we want to compute like the number of requests on 8 hours, 12 hours, 1 day. But obviously, there is a trade-off. The bigger the time window, the more costly it is for us. So we need to optimize it. And then when we evaluate the model, we want to ensure that it properly detects residential proxy IPs, so optimizing false negatives, all while not misclassifying human residential IPs, so optimizing false positives. So we use the AUC metric, area under curve, to choose the best model, and then we tune the model threshold using the F-score. Why F-score? Because in our case, we want to favor we want to minimize false positive for us. We care less about false negative in this kind of project, but we don't want to make too many false positive. And so the model we put in production has a false positive rate of 2.59% for a threshold of 0.9. Keep in mind that it doesn't mean that we block whenever an IP address is classified as a proxy. So it doesn't mean that we have a 2.59 false positive rate. Just the classification model has this false positive rate. But proxy detection is just one of the signals we use for bot detection. It's not the only one. So as of today, the model has been running in production for several months. And basically, it processes around 2 million residential IP addresses per hour. And the machine learning features are computing in a streaming engine, Apache Flink, on the 8-hour time window. So on average, the model detects around 500,000 residential proxy IPs per hour. Of course, some of them are already known because bots continue to make requests. So in this case, we just extend the duration of the labeling of the IP address. And so what we observe with this model is that at a given time, we have around 8.5 million residential proxies that are flagged by our machine learning model. And among the top autonomous systems, we have Comcast with more than 900,000 IP addresses, AT&T with more than 400,000, and then Verizon, 247, and other autonomous systems located in France and Poland. So to conclude, we conducted a study during almost a year, and we collected more than 354 million proxy traces, which represented roughly 30 million proxy IP addresses. These IP addresses are located all around the world, and in particular, we observed more than 3 million unique residential proxy IPs in the US. On some autonomous systems like Turk Telecom, we observed more than 11% of the IP addresses of the autonomous system that were used as a proxy at some point, which shows that it can be dangerous to just block, it shows how widespread the problem is, but you shouldn't block an IP address just because it was recently used as a proxy, but you should leverage the signal in your detection or in your investigation. We also observe significant overlap between the IPs of the different proxy providers and bot as a service, because most of them rely on each other. So if you want to build your own system to keep track of proxy IPs, which may not be really costly, you don't need to buy the proxy from all kinds of proxy providers. You can focus on the biggest one. I would be happy to discuss with you after to give you some name. It should be enough to cover most of the IPs. And so at DataDome, we developed a streaming-based supervised machine learning model to detect residential proxy in production. And thanks to it, we're able to detect at a given time, for example, more than 900,000 proxy IPs that belong to Comcast and 400,000 IPs that belong to AT&T, which means that it's really you have residential proxies everywhere, and the fact that a request is coming from a well-known ISP, you shouldn't trust it too much because it may be an attacker that that use proxy services to appear more human. Thanks a lot for your attention. We are located at booth 2734, so don't hesitate to visit us. Otherwise, I will stand next to the room after the talk if you want to ask me any question. We still have 2 minutes left, so if someone has a question, I'd be happy to take it. Yeah?
So, about your research, so my understanding is that you subscribe a service, proxy service, and then send the HTTP request to that one, and then you collect the trace. So what is your destination of those HTTP requests?
Okay. So let me share the question. Basically, the question was, okay, we subscribe to proxy services and bot as a service, but what's the destination of our request? What we do is we make requests to our own customers, not all of them, customers that agree to do it, but anyway, it's a relatively low volume of requests compared to their overall traffic. And then we put some things in the request so that we can keep track of it. That may look legitimate, if the proxy provider is analyzing the traffic, which they do, so we don't want, to get caught, so we make it look like, it's legitimate scraping request, but we know that it's not legitimate, we put some things to identify, and then we can flag that this request is coming from this particular provider. And for the passive way, we subscribe to the service, but sometimes they ban us, so, we use the free trial just to extract signature, and then, we keep track of the signature on our customer. It's not exhaustive because not all the requests will have the same signature, but these are signatures where we are sure that when we see them, it's from this service.
The next question is that, for example, you mentioned that Comcast, 3% of the IP
So does it mean that 3% of Comcast customers are compromised? No. Or maybe yes. Because like in our study, it's an upper bound. In reality, there are way more proxy IP addresses. So at some point, you know, like IP addresses may be allocated dynamically. So like it really depends on, you know, like, okay, today I'm here, tomorrow I will be somewhere else. If my device is compromised, you know, maybe today's IP will get flagged, tomorrow's IP will get flagged, but, you know, only one device got compromised. So it's difficult to count exactly. So I can't tell you if it's more or less, but it's just that at some point, you know, some devices were located on 3% of IPs of Comcast, and these 3% of IPs were had a compromised device. I will have to stop because it's already time, but I will be happy to continue to discuss after the talk.